When we talk about food security, it is still very much a global issue. And when we state food security, we say this is a state when all people at all times have access to safe, nutritious, and sufficient food to enable them lead a healthy life. There is one key integral player in the industry or in the food security space that has been integral in enabling us to have safe and nutritious food, and that is the laboratories. Today I'm honored to have this discussion on the future laboratories and how they will create infrastructure to enable us to continue to have safe and sufficient food. I will invite our experienced panelists to be able to help us dissect this issue. And I'd like us, as they come, please give them a round of applause and appreciate them as they come on stage. For the audience, in this particular discussion, please be keen, take some notes, and I'll invite you to share your comments and questions at the end of the panel discussion. So first up, I'd like to invite Grace Namagembe, who is a food technologist by profession. Grace Namagembe is a quality assurance manager and food safety team leader from B and Zika Poultry International Limited from Uganda. Welcome, Grace. A round of applause, please. I'd like to invite Professor George Ooko, who's the Associate Professor of Food Science in University of Nairobi, and he's also the chairman of Food Science and Technology Platform in Kenya. Professor George Ooko, please welcome on stage. I'd like to invite our next panelist, Peter Mutuku, who is the Technical Director, Sorella Scientific East Africa Limited. Please give him a round of applause, please. Karibu sana. Our next panelist is Mr. Sylvester Gule, the Managing Director of Nesvax Innovations Limited. Karibu sana, Mr. Sylvester Gule, if you're in the audience. I'd like to invite our next panelist, Mr. Rushab Shah, the Director of FNS Scientific. If he's present, please a round of applause for him as he comes on stage. Karibu sana. And lastly, our other panelist, Mr. Robert Ngeno, the Head of Technical Services and Product Application, Sorella as well. All right, I think that brings us to the end of the expected panelists for this conversation. And I'd like us to get into it, but before I do that, I'd also like to invite Mr. Owen, who is already on stage. Let's just give him a round of applause as well. Before we get into this discussion, I'd like to give our panelists an opportunity to introduce themselves in the next 2 minutes to our audience. Starting from Rushab.
Good morning, everyone. My name is Rushab, coming from FNS Scientific. So we are much like the other representatives here. We promote solutions focusing on quality and safety. And as Molly put it, laboratories play a key role in ensuring this. So one of the things that we can say is that we provide solutions across the entire value chain from farm to fork. So you got to remember that when we talk of food quality, when we talk of food safety, it's not only at the final step where the consumer goods manufacturer has to look after safety. Remember what they say, it's garbage in, garbage out, and anything can go wrong all the way through the chain. And there is a host of different solutions, very simple, easy to use, complex solutions that serve purpose across the value chain. And maybe just to add that the safety doesn't just stop at the point of a good being supplied to the supermarket. You got to remember that even the goods being supplied from the supermarket to your home nowadays with deliveries can also pose food safety issues if not handled well. So I think one of the things that I would like to just introduce ourselves as FNS Scientific to say is that we look at food safety, we look at food quality holistically from all spectrums, and we want to work with the customers to ensure that we're able to support you in enabling this and effectively protecting our consumers and protecting your brands as well. So thank you very much.
Thank you, Rushab. Mr. Peter.
Good morning, ladies and gentlemen. My name is Peter Mutuku. I'm a chemist. I've been involved in laboratory work for over 20 years. I've worked in public laboratory, like government chemists, whereby we've been analyzing foods and drugs, forensics, toxicology, forensics, and criminalistics, and so on. I've also been in other laboratories in the private sector. Currently, I'm the managing director of Sorella Scientific, whereby we distribute laboratory chemicals and equipment and reagent. And we've decided deliberately to focus mainly on the mycotoxins testing in pre-harvest, post-harvest management of the mycotoxins. And also, we are also distributing the equipment. We are also distributing the kits. Thank you.
Amazing. Thank you, Mr. Peter. I'd like to invite Grace.
Good morning, ladies and gentlemen. My name is Grace Namagembe, Quality Assurance Manager, Beanska Poultry International Limited. Once again, it's an integrated poultry management system with hatcheries, layer farms, commercial broiler farms, abattoir. So when it comes to laboratory analysis, Beanska Poultry International embraces many laboratory techniques to ensure that the final products we put to our market are free and safe for any hazards. So we do analysis in microbiology, like TPC, Salmonella, E. coli, Staphylococcus, the team in food science, and other scientific disciplines. You are aware of that. We do mycotoxins, not only in our feeds, but in our raw materials. In our dressed chicken, we test for mycotoxins to ensure that the chicken we give to the final consumers does not contain any aflatoxin levels that are dangerous to the health of the consumer. So all manufacturers, farmers down there, processors, please embrace laboratory analysis, because it's the way to go. Whatever you consume out there, you may not be sure of what it contains. It's only after testing. So laboratories help us in verification and validation of our processes to see that at all levels of production, our products are free and safe, so wholesome to the consumers. Thank you.
Thank you so much, Grace. I couldn't agree more on the role of labs in validating and verification of our processes and products. Mr. Owen, please go ahead.
Yeah, thank you, Molly, and good morning to everyone. My name is Owen Fraser, and I'm a scientist. I was the past president of the AOAC Africa section. I'm currently serving as a member of the board of directors at AOAC International. For those who are not familiar with AOAC International and AOAC Africa, AOAC is one of the world's premier testing standards development bodies. And most of the labs that would be testing foods would be using at least one of the AOAC methods. I'm also the co-founder and CEO of a company called Go Biosys, based in South Africa. And I think that's it for now. Thanks.
Thank you so much, Owen. We have another panelist who's just joined us, Mr. Sylvester Gule. I'd like to give you an opportunity to also introduce yourself. Karibu.
My name is Sylvester Gule, our director, Nesvax Innovations Limited. We are a Kenyan-based company for the last 15 years, offering solutions in terms of testing to the food and other disciplines in the country. What my experience for the last 15 years has been, when you started off, there was very little capacity in terms of what could be tested in this region. And it came with a lot of challenges, and that was the onset of some of these regulations. For the last 15 years, we've seen a lot of growth in terms of demand for these solutions. And we partner with about 15 solutions providers and manufacturers globally, of which one of them who are in this session today, SciAX. And with this, we are able to support you. We are able to basically test anything, food that you may require. Of course, we've seen a lot of changes happen, and at the moment we have a very young population as analysts, and there's also need for a lot of speed in terms of sample turnaround. And there's also a lot of development in terms of technology and solutions that come with it. So I think this is a very good session to try and demystify some of these technologies, and so that Africa can grow in terms of testing and the demands that are asked of us globally. Thank you.
Thank you so much, Sylvester, for that introduction. And you're already getting us into the discussion of the day. We all appreciate the accuracy that is needed, the speed that is needed when it comes to testing food samples. I'd like to hear from our panel, starting with Sylvester. What are some of the emerging trends in the industry that can help us, and in terms of laboratories, to help us get more accurate, more efficiency, and the speed of actually testing our food samples when it comes to lab? What are some of those emerging trends?
Thank you once again. Like I said, there have been a lot of changes. When we started off 15 years ago, it was more of a man's world in the labs. Most of the analysts I would meet were men. The last few years, we've seen the ratios balancing out. We have many ladies now coming as analysts in the lab, some of them being lab managers. And with this, it means that there's some growth on that score. We also have a big population of Generation Z and millennials joining the ranks as analysts. And with this also comes these challenges. Their demands are different. They want very quick results. And as providers, we need to respond to these. We need to develop, we're developing equipment, software, and hardware that can give very quick results. We also have to look at how to offer best support in terms of service. One of the challenges that Africa has had is that people procure equipment, but with no local support. Over the period, we built capacity to be able to offer that local support. And of course, there's a lot of technological intervention. For instance, together with SciAX has developed a VR-based support system where you can have your goggles in Nairobi, and somebody in Germany can be able to help you sort out a problem that is happening in a lab in Kenya. So again, most manufacturers are looking at how to integrate some of these technologies to be able to offer quick support, and also ensure that we have maximum uptime for each and every equipment. There's also a lot of move towards integrating artificial intelligence and big data to be able to ensure that the speed and the accuracy of the data that we get from the labs can be comparable to any destination or any lab globally. So again, those are now solutions that we are bringing in as players in this industry.
Thank you so much, Mr. Sylvester. And I think I'd like Rushab to just take on that point and be able to just expound on what are some of these modern, recent testing methodologies and equipments that are currently available to just help increase the accuracy, the speed, and efficiency of this data that we really need in the industry.
Yeah, thank you, Molly. So it's a good question, because when we say we're moving forward, does that mean we're getting faster? Does it mean we're getting more accurate? What is it that's happening? And the truth is, there's many, right? You have, and as I said earlier, you have complex solutions and you have simple solutions, but all serving the same purpose. So we can talk about, for example, aflatoxin testing. So for aflatoxin testing, we have solutions that are rapid, where you can get your results in a matter of minutes. and they're relatively accurate, cost-effective. But then you also have solutions which are, if I may say, more complex, which have a higher degree of accuracy, maybe a bit more complicated to run. And in doing so, you're getting possibly more reliable results. The question is the context of where those diagnostic tests are required. So, I mean, we're talking with Grace for Beanzika. You're getting raw materials. Sometimes you don't have the luxury of time to test those samples using complex technologies. So you get the rapid solutions that come in, and then you can verify them later with the more complex solutions. So maybe just to put it in summary, I think we do a lot of work, for example, in microbiology with our partner Neogen, who's one of the key sponsors here today. And even with microbiology, so we all know E. coli, we all know Salmonella, cholera, and all these other microbes or microorganisms of concern. The biggest problem with microbiology, I don't know if many of you are aware, is that you can only really test it by allowing that microorganism to grow, right? Now, when you need something to grow, it's called culturing. There is no shortcut for time, unfortunately. You need to give it 24 hours, 48 hours, 72 hours to grow. And then once it's grown, you then use some chemicals to try and identify, is it E. coli, is it Salmonella, whatever else it may be. Now, these companies, such as Neogen, have come up with what they call rapid automated microbiology techniques, where what they do is they take the conventional method. So for example, correct me if I'm wrong, but I think E. coli takes about 48 hours to grow. And from that, they've discovered that there are some indicators that they can use which appear within 6 hours or appear within 8 hours. So now, using the conventional gold standard reference methods, they've now come up with technologies that extrapolate that data to give you the results in 6 hours. Now, why is that important? Let's forget about the consumer for a second. Let's think about the manufacturers. Take Beanzika, take Biofoods, whoever it may be. They want to get their products out there faster, and they know they can't release the products until the results have come out. Now, in the case of dairy, the shelf life of your dairy products can be anywhere from 5 days to 7 days. Now that means that, say you've produced your yogurt or you've produced the milk and it's taking you 3 days to release the test result, that means you've only got 4 days left on the shelf, right? Now imagine you had a solution that allowed you to effectively release your products into the market 2 days earlier. That means that, one, your product is out on the shelf for 5 days as opposed to 3. It also means that the consumer can use the product with more of an assured guarantee that the product is safe and fit for consumption. So I won't really talk too much about the technologies, but the point to say is that everything is driven by what are the needs of the consumers, what are the needs of the manufacturers, with the same common, I guess, center point, which is quality and safety. There's no compromise. I think we all accept with E. coli, it can't be it's partially present. It's either present or it's absent. And if it's present, you can't consume it. If it's absent, you know it's fit for consumption. Thank you.
Thank you so much, Rushab. I think you have really emphasized on how the consumers and what they want is really shaping how the industry is evolving. I'd like Mr. Peter to take on to that, and now let's dive into technology. When we talk about robotics, AI, automation, how are some of those trending technological advancements shaping the future of laboratories from your perspective?
To answer that question, I think I must emphasize the need that you don't just test for the sake of testing, you test for the sake of trying to get an answer to make some decision. And then for that matter, it is important to have speed and accuracy of whatever you are testing. Whatever you are testing has got to be reproducible, it has to be accurate and acceptable. This goes for pathogen testing, food testing, and so on. So now the future now is rapid testing, reproducible testing, reproducible results, which is acceptable. So the future now is speed of testing. I've partnered with Hygiena. Hygiena is an international company dealing with such technologies. I have Mr. Sharif Hamad from Dubai. He's come to give us some support here. Maybe if I will ask him to show a little bit of what we are able to do. Mr. Hamad, please.
Amazing. Is that a demonstration? Amazing, amazing.
Thank you. Thank you very much, Peter, for inviting me here. Well, just to give you a quick look of future, this is my micro lab. Right?
Do you carry it everywhere?
Well, I carry my micro lab in my bag. Literally, I carry my micro lab in the bag. So this is the future. So thank you very much, Mr. Shah. I mean, all these companies like Hygiena, Neogen, we keep challenging each others. We keep challenging in developing newer technologies. So at Hygiena, we have a technology called as bioluminogenic assay, right? Now, as he rightly said, that you need to grow the bacteria to detect them. So what we have smartly done, those who are in microbiology field, we all know that the microbiological growth curve, the lag, log, and the stationary phase, right? So usually you count the bacteria in the stationary phase. In this new bioluminogenic assay, we count the bacteria. In fact, we don't count the bacteria. The instrument counts the bacteria in the log phase. So instead of counting at 48 hours, you count the bacteria in 6 hours. So that's the new bioluminogenic assay. And thank you very much, Peter, for taking out my micro lab. So as you can see, this is my micro lab. I can grow the bacteria on this small incubator and detect the bacteria on this device, which I showed yesterday as well. So this is a multi-application device which can detect total count, E. coli, coliform. So this is one of the rapid methods that has been developed, the bioluminogenic assay. Another method that is gaining a lot of traction, especially after the COVID outbreak, is the real-time PCR technology. Had real-time PCR technology not been here, the pandemic would have stretched. One of the main reasons of the pandemic being controlled is the real-time PCR technology, and you will be happy to hear Hygiena was the first company to come up with a COVID-19 test. Ours was the first real-time PCR COVID-19 test, which was developed in our German R&D center, and it was given to the world. Later on, many people came in, Chinese people came in, so lots of things happened later. So real-time PCR technology gives you the speed. Salmonella takes how many days? 5 days. Yeast and mold, 7 days. Legionella, 14 days. With real-time PCR technology, yeast and mold has come down to, you won't believe, but 5 hours. Legionella has come down to 6 hours. A quantitative test in 5 and 6 hours for yeast and mold and Legionella. Salmonella in 20 to 24 hours, right? So all these pathogens which used to take days can now be done in hours. So real-time PCR technology, bioluminogenic, ELISA is a 30 years old technology, 40 years old technology. But real-time PCR is the latest technology, and it's the future of testing in the laboratory. So, and many people think that real-time PCR is a big expensive equipment. No, not at all. It has become very affordable and low footprint. You have all seen pressure cooker, this size, round shaped. There is a real-time PCR size of a pressure cooker which can run your assay in just 70 minutes, right? So very low footprint, you can put it on this small table, a real-time PCR, and run your assay. So technology has become very advanced, but it's up to the regulators and the industry to adopt these newer technologies and take the advantage of it. Thank you very much.
Thank you so much, San. Before you go, I think the technology that you've presented is of very key interest to many SMEs, owners, and actually quality assurance managers in this room. I think of keen interest, what would you say is the cost for a small company to be able to purchase this from your distributors to have them in their own possession?
Well, I hate discussing pricing in a bigger forum, but if I talk about...
Maybe a range.
Okay, if I talk about a real-time PCR technology, you can set up a real-time PCR technology in something like 20,000 euros.
Okay.
That's it.
Okay, okay. What about this bioluminescent?
This bioluminescent assay,
Yes.
I guess something like $2,800 or something like that.
Okay. I think this gives us a hint and an understanding of what it actually takes. They've made it very cost efficient. They've also made it efficiency in terms of time, speed, and accuracy. So I think for those among us interested in actually purchasing this product, you now have an idea of what budgets to present to finance. Thank you so much, sir.
Thank you very much. Thank you.
All right, Peter.
Thank you very much, Sharif, for sharing that information with us. At least now you know. So for more information, maybe you can come to our stand out there, then we'll be able to discuss it further. The micro lab is here. Thank you.
Thank you so much, Peter. I think I'd like Grace to also chime in that discussion as we talk about the advances in technology. When you speak about AI, when you speak about robotics, when you speak about automation, what would be your perspective in how some of these global technological topics will influence laboratories?
Thank you so much, Molly. Actually, when we talk about robotics, artificial intelligence, on my side, we look at increased efficiency and accuracy in data. So when you adapt to new technologies in laboratory analysis, just know the level of accuracy and precision is high. For instance, if I use my NIR machine that is near infrared to do the approximate analysis for me without using the chemistry analysis, I'm very sure that the results I'm going to get using a near infrared will be similar to the results I'll get using the long method of the wet chemistry. So in such a scenario, this intelligence helps us to get more accurate data at a shorter period of time. It also brings in increased laboratory safety. What do I mean in this? Many times our laboratory technicians are exposed to a lot of microorganisms and chemicals used in the analysis. So if you use such machines, the exposure of the lab technicians is really reduced, and you'll find there is some safety for the laboratory operators. You get it when it came to COVID. Even the medical experts were fearing their patients for the first time. We've had several diseases, but we could not make people run away. But when it comes to the viruses, like Ebola, like COVID-19, even the medical experts themselves were really fearing to touch their patients. So we have to embrace the artificial intelligence, the robotics, and quick analytical methods to ensure the safety of the operators and the final products that are being tested. Thank you.
Thank you so much, Grace. And I think, Owen, finally to you. You can feel free to comment on the other perspectives from the panelists, but I also want to pose the question to you. In this new age, what do you believe are some of the benefits and the challenges that will come with aspects of AI, aspects of robotics in the lab sphere?
Yeah, thanks very much, Molly, and thanks to the panelists for their contribution. This is a very exciting area going forward. Of course, we've heard a lot about rapid methods. It's also very important to note that rapid methods are excellent for monitoring, but for compliance, to demonstrate compliance, you need to use a reference method, whether it's microbiological or chemical. And so the lab in the bag is great. It's nice technology. And it cuts down a lot of the time that you will need to do to release a product line or release a raw material for processing. But you still need to have a reference method to use. Of course, whatever method you use, the fundamentals remain the same. We must make sure that the methods are fit for purpose, meaning that it must be able to do the job it says it's meant to do, and you must validate the performance of that method as well. So sort of moving, looking at, currently, there are a lot of very exciting technologies being developed around testing for microbiology, of course, chemistries as well. But microbiology in particular, I want to make note of a technology that is emerging. It's been validated by a number of testing organizations. And that is following on from very much what our colleague Peter was saying earlier, was mentioning earlier, use of nucleic acid testing. But what's exciting about this newer technology is that it uses nucleic acid detection pre-enrichment. So you don't have to do the enrichment for several hours before you then get this readout. And so you're able to do for Salmonella, Listeria, multiple organisms, as well, using this technology in a multiplex format. So you can have a multiplex a panel which you can test for E. coli, you can test for Salmonella, you can test for Listeria, you can test for yeast and mold as well, all on the same panel, and it shortens the actual detection time to around 4 hours, 5 hours, 6 hours, depending on the organism of target as well. This is to come for the future. These technologies are not cheap. The consumables are quite expensive. However, they may cut a lot of and they may require a lot of robotic handling in order to enable the level of accuracy and precision and that will be required in industry. But so looking beyond that, there's a lot of exciting developments happening in the sphere of the laboratory environment. And the concept of the laboratory 4.0, and this is where there's a lot of new approaches to solve a lot of the issues we have in laboratories in terms of the infrastructure. And hopefully with my talk I will be able to expand a bit more on that, because that does have a direct bearing on how well those very expensive instruments that you will buy will perform in your laboratories. So I think perhaps, of course, all of that combined with LIMS systems that are able to be customized to speak to all of your instruments for the data input, to then use the benefit of AI for rapid decision making, and a whole range of things that you will benefit from that. Let's stop there.
Thank you so much, Owen. I think something I'd like to highlight from your submission is that you've highlighted how some of those equipment and the technology that comes with it can be cost prohibitive. And I think that is some of the challenges that food industries and SMEs will have to find a way to tackle. So I think I'd pose a question to all the panelists, especially the laboratory equipment suppliers. What can we do in the sphere of trying to really push the conversation of food safety and its actualization in the front of cost to be able to support some of those food businesses that are SMEs to enable them really comply with food safety? Maybe Mr. Sylvester, you can go first.
Thank you, Molly. Basically, I would say that with the onset of technology, for the equipment that we supply, there's a lot of robotic components in terms of sample introduction. At the same time, we are working towards an approach where you can have one software that can be able to control multiple equipment. So again, that results into some reduction in cost in terms of training that you need for your staff. At the same time, a lot of these technologies are expensive, but in the last few years, we realized a lot of the equipment that we provide at the moment, you have probably a lifetime of probably 15 to 20 years. So in most cases, you'll find that if used to optimally, you should be able to get your cost return on investment within probably 5, 10 years. So, and then another 10 years to get, now you get your profits. So again, the new technology, there'll be very little human interaction. So on the flip side, some jobs will be lost. But again, we realize that very soon we may have more data analysts running the labs than chemists. But again, that's a reality that we must come to terms with. So at the moment, there's a lot of partnerships that are going on between labs that are in Europe, because at the moment you find most of fresh produce. All the ports in Europe go to Hamburg. They have probably all the big contract labs have their labs there. So one of the approaches that is in the offing is to have a lab based in our ports, say Mombasa or GKA, and they can be able to share information. They can be able to, you can be able to aggregate all this information, all this data, and based on that, instead of having multiple testing at the cost of the producer or the exporter, you can be able to have the test done at GKA, and based on the systems that are in place, the labs in Hamburg can be able to confirm what has been tested here, and there'll be no need for multiple or a second test when the product reaches the port. So with that, the time that it takes to get for the product to get to the table there in Europe will be shorter. And with that, there is some benefit that will come with it. The cost to the producer will be lower because certainly to test here would be slightly cheaper than to test in Hamburg or in Europe. So those are now some of the approaches that we are looking at. And I think once these are implemented, there should be hope for the small enterprise to be able to access some of these benefits that accrue with this development in technology.
Wow, that is a fantastic, fantastic and insightful response, Mr. Sylvester, from the aspect of partnership and how the aspect of robotics and automation will reduce the amount of labor needed for our quality assurance departments, will increase the efficiency, and you've also given us the shelf life of the product and some of this machinery range from 2 decades, which can really help some of this company have return on investments. I don't know if you have something to add, Rashab.
I think he's covered much of it. Maybe just to think of this from a slightly different angle. And I think the point Owen made as well, that you see, no matter how much technology advances, it's still fundamentally built off the same principles, but it's how do we do things better, faster. And yes, anything is going to cost a lot more initially. We all know in Kenya and in Africa, we all know solar panels, right? Once upon a time, no one could afford solar panels. But now, if you think about it now, solar panels are readily available across the continent and actually supporting those who never had access to electricity. So in the same way, I think they mentioned PCR technology. Once upon a time, PCR technology was damn expensive. Now, it's almost becoming a staple in most laboratories. Like, for example, we work in healthcare. I think any healthcare laboratory you go to now, PCR technology is found. But if I can just ask, let's look at this from a completely different angle. You use the word cost, right? Can I just get a show of hands from the crowd today? How many of you have bought something from the supermarket in the last week or two and have had to throw it into the bin because it wasn't, you couldn't eat it? Show of hands? No? It seems like food is perfectly fine. I fail to believe that because I'm quite sure half of this room must have purchased something and then they've had to throw it in the bin because it was not okay, right? Second question, and hopefully you can raise your hands this time. How many people have suffered from food poisoning in the last 3 months? Okay, so quite a healthy crowd. So maybe my argument isn't going to stand that well. But what I was going to say was that when we look at cost, we mustn't forget who bears the ultimate cost if food safety and food quality isn't put to good use. It's the consumer, right? You buy a loaf of bread and you throw half of it in the bin. You paid, what, 60 shillings for that bread, but you only consumed half. So really, how much is the cost of that bread? It's double the cost. Now, in the same light, when the manufacturers like Bienzika, they buy raw material, if it's not safe to use, what do? You have to bin it. They reject it. But there's a cost, and who bears that cost? The consumer, because all these costs have to go into the final cost of the product. So when we look at cost, I think we must remind ourselves that cost is a very vague number to work with. It's ultimately, what is it doing? The truth is, in the rest of the world, and we have technology partners, as I say, I'm here on behalf of Neogen, which is a global leader in food safety and food quality. They are providing these solutions at far lower costs in other countries than they are here in Kenya, and that's because it's widely adopted and it's widely used, and it's almost any lab you go to that is doing food quality or safety has to be having certain technologies in place. Now, automatically, why is it that, for example, milk and bread is cheaper in Europe than it is here in Kenya? Doesn't make sense, right? So that goes to show that technology, and by the way, they're probably using far more advanced technology. I think PCR technology is now the gold standard method of choice in Europe, but we're struggling to adopt it over here. So all I want to ask you as consumers is ask yourself, if you could buy a product and be sure that you can consume all of it, you're likely to be more satisfied and you've wasted less money. So I think cost is not the concern. It's about wastage, spoilage, efficiency. And these technologies genuinely help. They genuinely help. We're talking from the chemistry side. We're talking from microbiology. We've got to remember also physical chemical testing. Don't forget that your eyes, your ears, and your mouth are also forms of testing, which we don't forget about. And I'm sure most of these companies actually have sensory tasting as a way to test whether the products are fit for consumption. Yeah. So I think just in summary, just to say, cost can be very misleading. Ultimately, what counts is the consumer. Thank you.
Thank you so much, Rushabh, for that contextualization and bringing us the cost-benefit analysis of really what is the cost of non-compliance when it comes to food safety. I think we definitely need to understand that it goes beyond human suffering. There is a lot of cost in the value chain whenever a product is found to be contaminated. The costs of recall, the cost of throwing away food from a consumer perspective as well, is really, really a high cost. So I think that really puts it into context for a lot of the companies here. Is it better for you to invest in that Neogena rapid testing kit that will cost you maybe $2,800 now and can last you for the next decade, or have products that are going to go into the market that will be rejected by consumers? You might have to do a recall, and that will cost you a lot in the long run in your business. So you decide for yourself. I'd like us to go into the next topic around traceability. As we talked about recall, traceability is a key component in the food industry. I'd like to hear from Mr. Peter. What is the impacts that blockchain is likely to have when it comes to traceability, data management in our food laboratories?
That's a very big challenge here in this country and elsewhere. Traceability of the testing and all that, it's very, very, very difficult. I would say it's very difficult. So there is also the element of the training of the analysts, the capacity of the laboratory, and so on. So there's I don't know. Do we have got any policymaker here? People who are in the ministry, or people who are in the regulatory affairs? Do we have? Academia, I think I've seen Dr. Food scientist. I don't know, I can't remember his name. So we need to have a way of addressing the way of food security and safety. And part of that agenda should be how do we reduce the cost of doing all that? We need to come up with a policy whereby now, as they are saying, now here in this country, there is a very big problem of food security and safety. Product for, or equipment for testing food products should be zero rated according to me. When it comes to mycotoxin, for instance, there was a time they used to be zero rated. You agree with me, mister? There was a time when mycotoxin testing used to be zero rated, VAT. Right now is 16%. Nobody has ever tried to advocate for the lowering of those taxes so as to make this affordable. So it's been a very, very big problem. So I would suggest maybe we can also, other measures should be now, we also need to look for a way of getting local solutions, educating people about all these things so that now we can be able to lower the cost of the testing. I hope I've understood.
Thank you, Peter, for touching on cost as well and touching on government in ensuring cost is actually something that is factored in this conversation. So I think I'd like Grace. I'd asked Mr. Peter around blockchain and traceability, right? If you can just chime on that topic from an industry perspective, as an industry counterpart, what do you think about traceability to begin with in the industry? And would blockchain have an impact of helping us be able to better trace our products from the bottom of the value chain all across to the market?
Yeah, thank you so much. The blockchain will help us on traceability. Why do I say so? When you look at most of the standards or regulatory bodies when it comes to food safety and quality, they have laboratories. And I'm very sure if you go to the Uganda National Bureau of Standards, all the results for Binzika Poultry International for samples submitted are in there. And when they come for audits, they don't need to ask you for your laboratory results. They only ask for your internal to compare with what they got when you are taking your samples for validation. So normally we are tracked. So if you failed aflatoxin B and total aflatoxin, they will tell you your feeds failed, this and this. Then they will tell you your dressed chicken failed, say E. coli, it failed Listeria monocytogenes, Clostridium. So we are really tracked. And if we go with that discipline, that even in our internal laboratories we are able to track, it will help us a lot. From my side of view, in our laboratories at Binska, we have a long-term tracker. All the results that are generated, they are entered into the system. So the CEO will not even have time to ask you, what did you get? He will just go into the system and see how the laboratories are faring. When it comes to ELISA, we use it for vaccine efficacy for our chicks and growing chicken. So you'll find a team drawing blood. We have samplers who go and take blood from the chicken. They come and test for disease and vaccine efficacy. So he will get to know all those results. And when it comes to the finished products like chicken, he will look at what you got in total plate counts, salmonella, and other pathogens, E. coli. Then he looks at staphylococcus and the rest. And he will see how are we performing via that. Are we on the right track? Are we ensuring food safety? Are our systems under control? So in blockchain and transparency, everything is manageable and you are able to track a consumer. You are able to track a manufacturer from that perspective. Thank you.
Fantastic, fantastic, Grace. I think that gives us a very good insight of how blockchain technology, once adopted, will help transform our traceability system. And as we wind up on this discussion, we've really talked a lot about the infrastructure of future laboratories and how technology will help us be able to cope with food businesses that are coming up. I'd like to pose this question to Owen. We are also looking at the human capacity. What are some of the skill set and competencies that human skill and the human capital need to be able to work in these future laboratories? And talk about training as well. What do we need to be able to cope?
Yeah, thanks very much, Molly. But perhaps I can just answer a question about the blockchain and traceability and the modern lab. So first of all, I agree fully. Blockchain as a technology would be excellent for improving traceability, quality safety, and so on. But that requires an integrated quality management system and quality assurance programs, of which the lab plays a very important part of. Unfortunately, we are very far away from that because you will need to establish a network where labs are willing to share fundamental data coming out of their whatever test they're doing in order to be able to allow that traceability. I think with the Lab 4.0, as we like to call it, will integrate such systems. But I think this is something that is not anywhere close by. What are the important characteristics or skills that are required by someone working in a lab? I think the first and most important thing is integrity. And we very often don't even think about that. Because you send your samples to a lab, you get a number, and then you make decisions on that number. Decisions as to whether to reject a material or whether to accept it, whether it complies or not. That number could be incorrect, but then you make decisions based on that incorrect number. And sometimes this comes down to the integrity of either the system that is producing that result or the individual that is working as part of producing that result. So yes, I would say integrity is perhaps one of the most important aspects of that. I think all of the other things, for example, having the right level of training, and I don't think you need to have a master's degree or a PhD to be trained to use a PCR or any of the other instruments. I think the technologies, of course, it makes it much easier for you to understand all of what is fundamentally important to making sure that the test is done reliably, accurately, and repeatable. But I think what is important here is for the training to be someone who is trainable, so they have a certain level of comprehension of the sciences, and then given the correct training and exposure to that as well, and coaching as well.
Fantastic. Thank you so much, Owen. I think to the young people in the crowd, you can clearly hear from the experts that you don't need a master's degree and a PhD to be able to participate or work in a lab. The most crucial skill that Owen has highlighted is integrity. At this point in time, I'd like to open up the audience to also participate in this discussion. Is there any question, any comment? We'll give a chance to one or two individuals to be able to ask a question to our panelists.
Nina Hamid again. I would like to know what support provided by the manufacturers and producers of this equipment and instruments and so on from Europe being brought here. For example, like if anything needs calibrating or it needs servicing or replacing parts, how easily and readable is that available to us here with the products coming from Europe? Thank you.
Thank you so much for that question. I think Sylvester and also Mr. Rashab and Peter can take on that.
Thank you very much. Basically, as Nesvax, we work with about 15 manufacturers globally, Europe and North America. One of the things that we insist on is the capability, the local capability, that is the local support for each and every partner that we work with. And this involves training our staff at their factory, having continuous training for the engineers, because in that concept we have engineers and application chemists, so that once the equipment are acquired, we are able to install, we are able to train the personnel to be able to use it, and we are able to offer aftermarket support, that is in terms of repairs and preventive maintenance, as well as consumables and parts that you need to get this equipment running. And one thing that we also do differently, and a lot with the support of our partners, is we have continuous seminars that we have together with some of the end users of the equipment that we offer to the market. So absolutely, we get a lot of support from the factory, from the manufacturers, so that we're able to have this equipment running near 24 hours a day. So like I mentioned, one of the pitfalls that was there in the market before was people were buying equipment but having no local support. So a lot of this equipment ended up in boxes. They got obsolete, never used, but that in the last 5-10 years have really changed. And we are demanding more of the manufacturers. We are demanding the capability, we are demanding the support so that we are able to get this equipment working. Another level of support is we have different chains of support. For instance, if it's a matter that needs escalation at the field, we have technology-based solutions that work. A new technology that we just introduced a few months ago was to have VR goggles for our engineers. So he can be on site here, but if there is a problem, he can be able to escalate this to engineer sitting somewhere in maybe in Europe or America, and he's able to see the equipment from the US and be able to intervene if needed. But again, at the moment, we demand a lot from the manufacturers, and they certainly come through for us. Sure. So basically, yeah. So basically, how it goes is at the purchase, there is a typical 1-year warranty, which covers spare parts and labor. However, after 1 year, there's option of buying an extended warranty, which comes at a price. But then as Nesvax, what we do is at the point of purchase, we recommend that we get into a service level agreement so that from the onset, you know that my cost of ownership, that is what I'm going to spend on labor, what I'm going to spend on consumables outside the parts that would not normally break, is this amount. And normally, we provide this information so that at the point of purchase, you are able to make that decision based on how much you are going to spend every year running that particular equipment. So again, there's warranty, but again, if you need more time on the standard 1 year, then it comes at some modest price.
Thank you so much, Sylvester, for that response. I think that has been very comprehensive. In the interest of time, we'll not be able to take additional questions, but I'd like to give our panelists one opportunity to be able to just share with us closing remarks about the future of laboratories and how they're equipped to support the next wave of food businesses and ensuring food safety. Maybe starting with Sylvester. Just 1 minute. Closing remarks. Oh, we go this way. All right, Owen, you're up.
Yeah, so thanks very much, Molly. And so when you hear people talk about their laboratories, they're usually saying, well, we are state-of-the-art. We are the best. It's quite often what they're describing is the equipment they have in the lab. It doesn't describe their performance, reliability of the tests they provide, and all of that. In fact, the vast majority of labs that we will see in the continent and other places as well, they have very nice instruments that are not working in an environment that actually is contributing to the instrument not working. So you don't have a stable, regular power supply. The quality of the water is unsuitable for the instrument. The benches are not suitable for the type of work that's being done. The room in which the instruments are, for example, you go to a lab and they're testing for toxic elements, so heavy metals and and other environmental content, so aluminium and so on. And they have a very nice ICP-MS, and the guy is very proud. We have the state of the art. It is the latest ICP-MS. But he has a broken window. He has a split air conditioning system that's blowing lots of dust all over the room. He has the auto sampler opened, and he has a sample running there. I can guarantee you, you will never be able to get a reliable result, regardless of how much money you've spent on the instruments and how much you've spent on training as well. What is equally important is to make sure you have an environment where those instruments, where those testing can be carried out in the way it's meant to be carried out. So, last couple of words is, when you're thinking of a lab, think about the environment in which you're doing that experiment to make sure that it's safe, that you have access to all the utilities, the environment is stable. It's safe, first of all, for the people who work in it, as well as the environment, whatever comes out of that lab. And there are several other things that one should consider, including adaptability and energy consumption and so on. So I'll stop there, otherwise I use everyone's time.
Thank you, Owen.
Yeah, so thanks.
Thank you. Grace?
Thank you so much. My final remarks goes to all the food processors down there. Please embrace the future laboratory. At one time, let every processor try in as much as possible, set up a minimal laboratory and try to adhere to the standards, because the standards are available. The ISO 17025 is there to guide you on how to operate a laboratory safely. And this will help us to come up with rapid corrective measures which can help us in case we encounter any issues along our processes. So in case you test your product internally, it's easier to detect an issue before it reaches the regulatory body. So if you test internally, you are able to come up with corrective actions and proper preventive measures that will help you calm down the situation before that product reaches the final consumer, or before the regulatory officers pick it from the stalls of Carrefour. So it will be better you do internal analysis to be able to calm down any issues that are related to food safety. So make sure laboratories are available at your facilities. And in case you need any technical expertise somewhere, please recruit the right people and also seek for expertise outside, like from the people who are manufacturing or the people who are distributing consumables. I'm lucky, like on my panel, on this panel, I have one of our distributors, one of our suppliers for laboratory consumables and equipment, and these people have been so vital in our lives that they have impacted a lot of trainings to our staff in the laboratories. So whichever technology they come up with and they bring it to management and they accept, they always come in and do the necessary trainings and ensure that the consumables reach on us at the right time without any delays. Yeah, thank you so much.
Thank you so much, Grace. Mr. Peter, 1 minute.
For me, my take is testing or equipment is very, very expensive. So for all the manufacturers who are here, you need to come up with a solution of trying to lower down the cost of the equipment and the consumables, so that now we can be able to test. We can have as many people doing testing as much as possible. There is no point of having an equipment worth about 20 million shillings and people are not testing. It doesn't really make sense. We need to look for a way of bringing down the cost of the consumers, the cost of the equipment, and possibly maybe also ask the governments who are involved to look for a means and ways of reducing the taxation so that we can be able to afford the equipment. Thank you.
Thank you so much, Peter. Rushab?
Thank you, Molly. Yeah, just to close, I think your question was the future of laboratory. As we've seen it, I'm sure there's a future where there'll be a fully automated laboratory where there's possibly no human in there. It's a box and you put your sample and the results come out on the other side. There's probably a future of laboratory where you're getting your results at the palm of your hand, where everything is being done on your phone. Who knows? I think there's a lot of technology that is being discovered that is yet to be deployed in the laboratory, so we're waiting to see what's going to happen. I think for the laboratory professionals, what that means is that they're going to be playing a different role. Maybe they're not going to be so involved in the lab techniques, but more what do we do with the information that comes out of it. And I guess the bottom line is to say is what is the future of laboratory? It's simply what the consumers need. I think everything is, whether we like it or not, everything is governed by the consumer, and that's what we work back towards. So as long as it works for them, it works for us. Thank you.
Thank you so much. I love how customer-centric you are. Please, Sylvester, last words.
Well, Molly, I should have taken my chance. The beauty of talking, or the bad thing about talking last is that you sound like a broken record. However, I would say that there'll always be new approaches, new technology. The challenge is how fast are we ready to adopt these? Unfortunately, we've become a global village, and there's no way we can be left behind. So, in a sense, we need to adopt this technology, and there's a lot of need for partnerships between different labs. This is something that is not happening, but we hope this is going to happen over a period of time. And of course, just to try as much as possible through these partnerships to have efficient systems that can serve the consumer ultimately. Thank you.
Thank you so much, Mr. Sylvester. I think we can all agree, audience, that the best way to predict the future is to create it. I'd like to appreciate our panelists and say thank you so much for giving us a glimpse of that future. Please give them a round of applause. Thank you so much. You may have your seat.